My name is Shane Hutson. I'm an associate professor of physics, secondary appointment in biological sciences at Vanderbilt University. I teach introductory physics for the purposes of what we're doing here. We have split our introductory physics course into two courses, one that's targeted towards pre-med students and one that's targeted towards engineers. I teach mostly the pre-med directed course, although it's still a calculus-based introductory physics course. For pre-med students, certainly, there is at least one more time they're going to have to be able to use physics, and it will come a couple of months to a couple of years after they take my course, and that's when they take the MCAT. And so I try to be very explicit about that from day one, right? It's something that motivates them. I might as well face it and use it as part of the motivation for the classroom. And so I try to be very explicit in the syllabus about where the topics we're talking about in physics line up with things they're expected to know for the MCAT. They just released a brand new report on sort of scientific foundations for future physicians. It had all these competencies that students are supposed to know, and so we lined those up with the syllabus and made that available to the students from the start of the semester. And then as we went through the semester, I would mention in class a little bit, not a great deal in class about the MCAT, but we had a few questions that we really did pull from the MCAT, and we did those as example questions in class. The students know they need to be able to at least refresh their knowledge of physics before that exam, and so the more they learn now, the less they'll have to do then. I mean, I would be disappointed in myself if I thought I was teaching to the test, right? That would be miserable to do. But you got to be familiar with it. It's part of the student's motivation, and so I want them to know that I'm familiar with what they're going to face and that I've thought about it to some extent in terms of what I'm teaching them in the classroom. So the two low-stakes assessments in my course both feed into something I call a participation grade that counts 5 points towards their overall score at the end of the year. And those are some online warm-up questions, which are open-ended questions where basically I ask them a question about the real world, something concrete. I don't use the physics language, and the idea is they're supposed to pull out of the reading from the text for that day the connections to the physics we'll be talking about. And then a second one is just, what do you find difficult, what was hard, and they answer that. And so they get credit for that basically just on effort. Did they try? Does it look like they're reading the material? And so grading that's very quick. They did or they didn't, right? I don't spend a lot of time on it. The second one is using clickers in class. Over the course of a semester, I probably ask about 150 clicker questions. So there's 3 to 10 of them each day, right? That's sort of the basis of what's going on in the classroom. And the students get some credit for that. Largely, they get some number of points for getting it right. 5 is what I use, or 7 is what I use for getting it right. 5 for answering it all. And so the only way they really hurt themselves is if they don't participate, if they don't answer the questions. At the end of the semester, I add it all up, and they only have to get about 75% of all the points that were available to get their full 5 points of participation credit. So that takes away, right, that makes it even a little bit more lower stakes. You can forget your clicker one day, your batteries can die, and it's not the end of the world. You're still going to get the full participation credit. You don't have to do everything, but you got to do most of it. Well, remember, these are pre-med students, so they are definitely grade motivated. No doubt about that. You have to meet them where they are, right? They're grade motivated, so you use that. If they realize, 5 points can make the difference between B, B minus, B plus, A minus, right? These matter. And so they're willing to do it with just a few points put on the line, right? So that's sort of how I motivate them to do it initially. The points are there to get them to try it. And hopefully by the time they get through the first or second exam of the semester, they realize that these low-stakes assessments have gotten them ready to do well on those, right? And so that means being very careful about tying in exam questions to questions they've seen with the clickers or questions they've seen as the warm-ups before class. And I have to be very explicit about that. I mean, there will be probably a question on the exam that is an exact copy of a clicker question and a few more that are modifications, so they have to think a little bit more on them, right? But they have to know that it's coming up and that these things are going to help them when assessments come along that will have a much bigger impact on their grade. I think one of the biggest problems students come in is not only misconceptions about physics or thinking that they're not good at physics, is that they don't know how to learn physics. And so, yeah, a few points on the line initially to get them to try these methods, and then they realize, oh, this is working. I'm learning something. There's things that are sticking. When I go back to study for the exam, it's not all new to me. I'm not just memorizing formulas or memorizing a few key concepts. This stuff has been drilled in because I've used it over and over again. In terms of how the low-stake assessments prepare students for what I really do expect them to be able to do on an exam, which is more than simple plug and chug with formulas. It's really having a deep conceptual understanding of the physics. I think the low-stakes assessments, especially the clicker questions, really prepare them for that from day one, right? So it's okay for them to get those clicker questions wrong. I don't expect them to be perfect right off the bat. But they see what the expectations are for what they have to do later. And so the clicker questions can't be in themselves simple plug and chug. They have to be involved conceptual questions. So it's this balance, right? You don't want one of the clicker questions to take up more than 5 minutes of class, right? But it's got to be well targeted to some concept that you want them to deeply understand, and they have to think just a little, but they don't have to do in-depth calculations or anything like that, right? And so there's a lot that goes into the design of the questions to make sure the students know what your goals are for them, that what you expect them to be able to do come exam time. They see them initially as just practice for the exam, but I see it as pushing them a little bit beyond their comfort envelope, right? Asking them to do things that are hard, right? Students are going to do the easiest thing they can get away with. It's what people do, right? You put them in a circumstance, the easiest path to success is the one they're going to take. And so you've got to make the things you don't want them to do hard and the things you do want them to do easy. And so that's what comes into the design of questions, is how do you make it so the plug and chug route won't get you to the right answer, but having a confirmed conceptual grasp will easily get you to the right answer.